Okay, good morning once again, children. Welcome to BBIS e-learning, episode 1 for JHS 2. And like you can see, I'm Sir Dennis and I'm here to take you through mathematics, specifically the topic Pythagoras theorem. And the main shape you are going to look at is the right-angled triangle. Children, by the end of this lesson, I expect you to be able to define and draw appropriately what a right-angled triangle looks like. Then secondly, I would want you to be able to label them appropriately. Then lastly, I want you to be able to state the Pythagoras theorem as a mathematical expression or equation and be able to use it in finding any unknown part or side of the right-angled triangle. So you would ask, what is a right-angled triangle? In our previous lessons, we have done it already. And if I ask you to recall right now, you will tell me that a right-angled triangle is any triangle that has one of its interior angle being a right angle or being equal to 90 degrees, right? Yes, we have done it already. So more often than not, I've told you our vertical, our horizontal to give us our right angle. Then you just join this side and you have your right angle triangle, right? Good. So this is a triangle we are going to deal with. And this mathematician, Pythagoras, this is the triangle that he centered on, which helped him in finding the length of so many triangles that we have. So now we will pay attention to the parts of these very triangles so that it will help us in how to use the formula in finding an unknown length of this triangle. Now, first and foremost, I will want you to know what the hypotenuse is. Almost all the time, we say the hypotenuse is the longest side. This side is called a hypotenuse, and it is the longest side of any right-angled triangle. Then, any of these two sides can either be opposite or adjacent. At your level, we are not much interested in the specifics. If you mention or accord this place opposite, then this place should be adjacent. If you accord this place adjacent, then this place should be opposite. So if I have opposite, as you can see, then this as adjacent, as you can see, what variable will you want me to represent the adjacent with? Obviously capital A, and this one is what? Capital O. Now, I want you to understand something. At this level, you do not draw to scale. And when we say you are not drawing to scale, it means that you are not using ruler specifically to tell the exact length. So I can draw a right angle triangle this way, and yes, this way. And much as I have said that the longest side of a right angle triangle is the hypotenuse, you are tempted to believe that it is either this place or this place which can be the hypotenuse. But children, no. Because you have not drawn this specifically, we expect that you use other indicators to tell which side is the hypotenuse. And I'm here to tell you that wherever your 90 degrees is, where the point is facing, that is your hypotenuse. So in this case too, you can see that this is my 90 degrees. It is facing here, so this will be my hypotenuse. So this can be my opposite, this can be my adjacent, because we are not drawing to scale, remember? Is it clear, children? Good, we are good to go. So if I draw something like this, and I do this, and I have A, B, C, we want to know the hypotenuse so that we can accord the adjacent and the opposite, right? So I want to ask, is B the hypotenuse? Obviously not. Is C the hypotenuse? No, but A is indeed. Why? Because it is opposite to the right angle, 90 degrees. Having understood that, let's go on to the mathematical expression by Pythagoras. Pythagoras realized that anytime you square all these sides and you add the opposite and adjacent, the squares of the opposite and the adjacent, it always gives you the square of the hypotenuse. That is what he found out, and that is how mathematics, sometimes in the course of doing things, you find out a formula that have not been found out by any mathematician. So this is what Pythagoras said. He said that the sum of the squares of the opposite and the adjacent is equal to the square of the hypotenuse. He didn't say the sum of the opposite and adjacent. He said the sum of the square. So first you have to square them before you sum them, and it's equal to the square of the hypotenuse. So you have adjacent squared plus opposite squared, giving you what? Hypotenuse squared. In other words, if you want to bring the hypotenuse first, hypotenuse squared is equal to adjacent squared plus what? Opposite squared, children. Now, you remember very well when we did a change of subject. Whenever you have something like this and you want to make h alone the subject, once it is carrying a square, what do? You square root towards both sides. You are right, so that these two will cancel out the square root. I've told you that always square cancels out square root, so that you have h is equal to the square root of what? A squared plus what? O squared. But bear in mind, children, it is not all the time that I will ask you to find the hypotenuse for you to always stick to this. We have done change of subject once again. So even having understood that we have hypotenuse square is equal to adjacent square plus opposite square, if I ask you to make A the subject, what would you want to move first? You know it. We'll move O squared. That's the opposite squared first. So we have hypotenuse squared what? It is plus, and I've told you that anytime the plus sign is crossing the equal to sign, it becomes what? Minus. So minus opposite squared is equal to what? Adjacent squared. But bear in mind, we are not looking for adjacent square, we are looking for what? Adjacent. So what do? Again, we square root both sides, then the square cancel the square root sign. So it means that the square root of the hypotenuse squared minus opposite squared is equal to the adjacent. And you can do same in finding the opposite. It's the same thing. I hope you have understood to this point. Okay, so children, I want us to take some examples and try our hands on. A very simple one. Now look at it. Let's say you have this place as 3 centimeters. Now let me indicate this, okay, just to see if you have understood it very well. Okay. So let's say we have 5, we have 4, we have x. Children, we want to find x. But first of all, you want to label and be sure of exactly what your labelings are so that you can appropriate them very well on the formula. Okay, so what is first and foremost our hypotenuse? It's true, the 5, right? And what is our adjacent? Indeed, the x. And then opposite 4, right? Good. So if you are saying a squared is equal to o squared plus a squared, and you have agreed with me that our h is the 5 centimeters, let me give it units. Our o is the what? X centimeters, and our a is the 4 centimeters. Putting it into this formula, what are we going to get? Substitution. So h is 5. So in place of h, what do we put? 5. So we have 5 squared is equal to, in place of o, what do we put there? The x. So x squared plus, in place of a, what do we put there? 4 squared. But we are looking for x. So what do we do now? We make x the subject by moving what? The 4 squared. So we have 5 squared minus 4 squared is equal to what? X squared. Good. So 5 squared gives us what? 25. Minus 4 squared gives us what? 16 is equal to what? X squared. So let's come back here. 25 minus 16 is going to give us what? 9 is equal to x squared. But we are looking for x. So what do we do again? We square root both sides. So we have square root of 9 is equal to what? X, because the square will cancel the square root. But square root of 9 is a perfect square. So what number gives you that? It's obviously what? 3. So it means 3 centimeters is equal to the x we are looking for. Or you can rewrite that x is equal to the 3 centimeters, or is equal to 3 centimeters. I hope that was very much smooth. Let's try another one. Try this one quickly. Let's say you have 12 centimeters, you have 5 centimeters, and you have 10 centimeters. Children, how do you go about this? I've told you, you always have to find your labelings and appropriate them. But always find your hypotenuse first. So what is our hypotenuse over here? It is n. right? So we can just go h is equal to m centimeters. Then we have a. I want to use 5 as my a. Then I have my o as what? 12 centimeters. So quickly, let's write our formula. Let's go. H squared is equal to what? A squared plus what? O squared. Good. Then we do what? Substitute, right? Good. What is our h? M. So m squared. What is our a? 5. So 5 squared plus what is our o? 12. So 12 squared. So we have m squared is equal to 5 squared means 5 times 5. Good. So giving us what? 25 once again. 12 squared means what? 12 times 12. You know 12 is what? 144. And when we add 144 and 25, what are we going to get? We are going to get 169. How did you get that? 144 plus 25. Placing all digits at their right places. So we have 96169. But we are looking for m. So what do? We square root both sides. Good. So the square is going to cancel the square root again. Then we're going to have square root of 169 giving us what? 13 centimeters. Clap for yourselves. Great children. It has been quite wonderful coming your way in the comfort of your homes with a wonderful topic like Pythagoras theorem. But as is very typical of me, I want to quickly wrap up my topic. So what have we done so far? We have looked at the Pythagoras theorem, and specifically with reference to the triangle that he based his theory on, the right-angled triangle. And we said, what is a right-angled triangle? It is any triangle that has one of its interior angle being equal to what? 90 degrees. And we also said that the labeling of the right-angled triangle is not as a result of any drawing to scale, but rather based on the position of the right angle triangle. So once you are able to find where your right angle is, the 90 degrees is, the side opposite to it is the hypotenuse. Then the other side can be accorded opposite or adjacent. Then we came by the formula a squared is equal to a squared plus o squared as his theoretical formula. And so any other thing is all about what? Substitution. And we have looked at quite a number of examples. I believe you have been able to grasp this concept very well. Again, we have given a lot of e-materials to your parents. Make sure that you reach them, get them, exhaust them. If you exhaust them and you want more examples, you can resort to the internet for more examples. However, before I come your way again, make sure you adhere to the strict rules of your parent. Don't go out. Sanitize your hands when you are supposed to. Wash your hands very often. Don't mingle with people. Don't be shaking hands with people. And stay safe in the face of this COVID-19 pandemic. I'm very pretty sure that I'll come your way again with the next lesson. But until then, I say, keep working math, because it is like what? Like a game. As you play it, you become a master at it. Thank you very much. It has been said. That is once again taking you through these mathematical lessons. Bye bye.